solving equations, these are going to be literal equations. Literal equations meaning we don't come up with a numerical solution, but rather we are solving an equation that has variables representing different things that you would see in science, physics, things of that nature. So we want to solve for C in the first example. So that means everything needs to move except for the C. So what do I move first? Divide by the M. And I get E over M is equal to C squared. Now what? Square root both sides. So the square root of E over M is equal to C. Awesome. You might say, well, write the plus or minus. You know, I don't really know if the constant is positive or negative. I mean, they'd figure that out in context of the problem and the application for science. So don't have to get too technical. Try B on your own. Try to solve for M. I've got R squared over TG is equal to M. How's that look? Okay, so now I'm going to show you one that you haven't seen before. You probably haven't seen a problem like letter C. We're going to solve for X. What makes X more difficult in this problem? Okay, there's numbers and letters. There's addition and subtraction. There's multiple X's, okay? X occurs in two places. Now, here's the problem. Everything we've done up until this point, you've seen from last year, okay? It's been quick, but you've seen it from last year. This you didn't see. And I'm telling you, you have a problem almost identical to this on the test. You need to be able to solve for this. I have one here. I have one in your assignment. I have one on your study guide. So don't show up to the test and write this. The 3 word letters that I hate. I hate that. Don't write that. Okay? Don't do that. Okay? You should like circle this would say, oh, for sure know that one. Okay? So here's what we do every time. First of all, we'll get rid of the fraction by cross multiplying. 3rx minus 12 is equal to 2px minus 2r. And trust me, this is a skill that I'm teaching right now that you will use in calculus. So, once we get to that spot and you recognize you have x's in 2 places, the first thing that you do is gather the x's together. So if I gather the x's, I'm going to put them on the left-hand side. 3rx minus 2px is equal to 12 minus 2r. Everybody okay with the first 2 steps? So now, what do you think I do to isolate just one x? I have 2. What could I do to make it so there's just 1? Factor out the x. You factor out the x, what are you left with? Now I just have 1x. So what's my final step? Divide. Not too bad, huh? Nice little trick. Okay, just factor out the x and all of a sudden it's isolated. So we try next one. You tell me, what do I do first? Distribute the 4. So where do you want to put them? Okay, we'll put them on the left. Factor out the x. What if, instead of coming up with 4y minus 5 over 3b to the third plus 4, what if I came up with 5 minus 4y over negative 3b to the third minus 4? Is that the same thing? Why? It is the same. Why? A negative on the bottom and a negative on the top would factor to the same thing, right? So if you would have put your x's over on the right-hand side, you would have come up with this. And either answer is acceptable. Everybody okay? So if you check the back of the book, you're like, oh, we don't have the same answers. Try factoring out the negative on the top and bottom, and you should be the same. Okay. Last example. A ball that is thrown into the air with an initial velocity of 45 feet per second and an initial height of 6.8 feet has a height that is modeled by the following equation in terms of time. So if you want to know the height, it says you take negative 16 times the amount of time it's been in the air squared plus 45 times the amount of time plus 6.8. Now here's what's interesting for those of you going on to take any type of application sciences. The 45, that is always your initial velocity. Velocity is the same as speed, but velocity also has direction. It can be positive, it can be negative. Yes. I don't hate science. I just like to get a rise out of Miss Kiesler. So she's so easy to pick on. So, but she's got Mr. Blotty on her side. He's kind of a bully, so intimidating. And that's always the initial height. Still searching. So now we have the negative 16. So this is the initial velocity. This is the initial height. Negative 16, that stands for the constant of gravity. So gravity always has a negative force on objects as it's pushing to the ground, it's pushing downwards. So this negative 16, when you work in feet, that will always be negative 16. If you're working in meters, then it'll be a different measurement. Anyway, so question, we're going to change a couple of these things. We're going to get rid of problem B. We're going to change that to 2, okay? So what is the height of the ball after 2 seconds? How would I figure that out? Just plug in 2. And you get h of 2 is equal to negative 16 times 2 squared plus 45 times 2 plus 6.8. So I take out my handy-dandy calculator. And I get 32.8. 32.8 what? Yes, our measurement is going to be in feet because we're measuring height. So what if we were wondering at what time does the ball reach its maximum height? Well, let's look at that equation. If I were to graph this equation, what kind of shape would it make? Probably right side up or upside down? Upside down because of the negative coefficient in front. So there I have it. And what is that point called where it reaches its maximum? It's called the vertex. What is the equation for finding the vertex? Negative b divided by 2a. Good job. Now, for those of you who can't remember that, let me show you that you've always known it. Quadratic formula. Notice how it has a negative b divided by 2a? That's the whole point of the quadratic formula, folks. The x value is negative b divided by 2a, right? And then look, plus and minus. From there, you add on to get one x-intercept. You subtract off to get the other x-intercept. That's all it's doing. So if you know the quadratic formula, you know the equation for the vertex was negative b divided by 2a. So good. All right. So let's do it. Negative b. What's negative b? Negative 45 divided by what's 2a? Okay, and so I divide. .41. I'll round to the nearest hundredth. 1.41 what? Seconds. At what time? So 1.41 seconds. So if I want to actually find the maximum height of the ball, what would I do then? I know the time it reaches its maximum height. What would I do to actually find the maximum height? I would plug that in. Negative 16 times parentheses 1.41 squared plus 45 times 1.41 plus 6.8. Got 38.44. What? And the last question, what time does the ball return to the ground? How would I go about figuring that out? If it hits the ground, what's the height? So the height is 0. How do I solve that equation? Quadratic formula. Squared minus 4 times negative 16 times 6.8. And that will give me the discriminant value of 2,460.2. And if I square it, the answer, you get 49.6. So negative 45 plus or minus 49.6, I'll divide by negative 32. People familiar with this answer option? As opposed to plugging the number back in, you can just hit second negative sign, which is answer, and it'll take the last answer to come up and use that. Very helpful when we get to trigonometry second semester. Okay, so great. I've got this thing. Well, that doesn't really tell me what time. I don't really understand what that means. So what do I do? Okay, so we'll take negative 45 plus 49.6, and then I'll divide it by negative 32, and I get negative 0.14. Negative time probably doesn't make sense in terms of the problem, so we'll try the other one, negative 45 minus 49.6, and we'll divide that by negative 32, and we get 2.96. Which one do you think is the correct result? Yep, 2.96 seconds. That would be the time at which it hits the ground. So it's in the air for about 3 seconds. Good? Your assignment is on your homework cover sheet. It's the third one from the bottom. Assignment 1.5, page 58, numbers 53, 54, 63, 64, so on and so forth. Did I give you guys one of those? Got it, Michael? That's what you staple to all your homework and hand it in the day of the test. It's the third from the bottom.